So hello and welcome to a new webinar here from Betzigau. Today we are focusing on the power industry, and as always I have support by my side. Today I have our expert for the power industry next to me. Hello Julian.
Hello Nicolas, thanks for the introduction, and also welcome from my side to this webinar today, Power and Energy, as Nicolas already said. And we do have also something special. But first of all, today we are not gonna talk about RN4, so with a plastic vein, plastic process connection. Today we are gonna talk about the big boys. Here for the Nivo guide with a coax version, and also an RN 3003, so the heavy duty version, so the reinforced ribs version. So it's going to be a tough webinar with tough applications, but we do find a solution for almost every application here today.
And beside those tough guys, we do also have one specialty today. Julian, please tell us more about the specialty.
As you may know, we do come up with a CN7 redesign. So a new almost complete new unit, for a capacitive unit for the liquid application. And we thought today it's going to be a good idea to have the chance to win one of those new CN7 redesign. And we do talk about different applications, and at the end of the webinar we do have 5 questions, and you need to answer these 5 questions. Next slide, please. Here you have the chance today to win a brand new CN7, and you need to answer 5 questions at the end of the webinar, and all questions need to be answered correctly. And after the webinar, you have 10 minutes time to send an email to export@uwt.de. So there's also the email address where you send normally orders. Only question 1, A, B, C, or D. It's only one answer is correct. And after this, you have the chance to win one of those units. It has a list price value about 230 euros. So it's absolutely worth to take the chance. Stay at the end of the webinar, it will be worth, and you have a good chance to win this. All right. Today, power. We do talk about conventional power plants, and the principle is almost the same. You have a fuel that is burned, and then a turbine is driven, and the generator and the power plant generates the kinetic energy to electrical power. And the only difference is that the material you burn is different. You have on the one hand side coal, or you go for natural gas, you have oil, and also nuclear power. For nuclear power, the emission is very, very low, but at the end you have the radioactive waste, and this is also a huge problem. And also coal, we have coal for the next 200 years, but it does not. We only have this amount of coal in the world, and also the same with natural gas. It's really expensive because it comes in Germany. It comes from Russia, and we also have other possibilities to generate power. We have wind parks. Also, we have the possibility to go for tidal power. For example, when you live close to the ocean, that's a very good solution to generate power, or also biogas plants here. But today we're going to focus about coal, because here we have many possibilities to place UWT in their applications. Special requirements. Today it's a dusty environment, and we said we have high temperature units, high temperature application. We have mechanical forces, we have corrosion, we have sticky material here, We do have condensation when it's cold air and hot air when it comes to condensation, and we also have dust exit approvals, what is also very, very important in this industry. Here we do have a flow chart where we have a deep look what is going on in the coal power plant. And today we do deal with coal handling system, we do deal with ash handling system, and we do have steam and water system. So these three topics we took into consideration because here in this part we do have many, many possibilities to place UWT devices. So the first thing for coal handling system is conveyor belt. And here, what kind of unit, Nicholas? How did we solve here these application in the conveyor belt? Because it looks very difficult, and yeah, we need to put some more time to have a look in this application.
Yes, exactly. So maybe you know this application already from the steel industry. So we are also handling with coal there, but this was one application from a power plant. So we used our RF Nevo for the conveyor belt to position the conveyor belt. And what was the specialty? That we had a lot of abrasive material, so the sensor is pretty abrasive resistant, and we can adjust the sensor for a contact or a non-contact measurement. So as you know, the conveyor belt should not come into contact with the material because then it will be damaged. So this has to be avoided, and for this we use the RF Nevo to control the conveyor belt. And now I can show you what I mean when we were talking about non-contact or contact measurement. So here we have the RF Nevo. You can see the red light that it's not on, and when I go now near with this plate, you can see that I don't have that the sensor does not touch the plate but is yet reacting. So this is what we call non-contact measurement, and I think we have the same with the CN7. So here again you can see the green LED. So when I get near with the plate here, then it reacts, although we are not touching the probe. So I'm far away from the probe and it still reacts. So this is what is possible with capacitive technology. So you do not even have to touch the material, but the sensor gives you the output signal.
All right, perfect. Thanks a lot, Nicholas.
So another application.
Here we do stay now with the coal handling system, and right now we do talk about raw coal storage. We do have some main challenges here. So we need a fast response time. We have a difficult installation conditions. We do have the size of the varieties is from big to very small. So you have also the material surface is different. What we see in a minute, because we provided a short video here, and also the size of the silo is between 20 and 40 meter, and many things we need to have a look on. Also for the Nevo, for example, if you can consider that we have 600,000 measuring cycles until we need to replace the mechanical part of the Nevo, so quite a lot. So you have many possibilities here to adjust also the Nevo on the application you need.
Exactly, and for the raw coal storage, some applications here. So the RN 3003 in a coal chute. So the heavy duty version with the angled extension. So Rubber's design here We have a lot of stainless steel around the shaft to protect it. Then we do have the Nevo bob in a coal digout. So here the specialty was the long socket pipe. So we have the modular design of our sensors. You can configure the sensors always with regards to what the application really needs. So here was it a long socket tube due to the installation conditions, and of course the non-contact radar technology, the Nevo Radar 3100 in a cold stockpile. So here we have the 78 gigahertz FMCW technology, so we get stable measurement results and pretty reliable. And also due to this higher frequency, we have the narrow beam angle, so we can cut through narrow spaces and small installation conditions. So here are some examples for what we already solved for the raw coal storage. So here you can see the video what we installed here, the Nevo radar on a conveyor belt, and the Nevo radar controls the complete level of this stockpile here.
And due to the fact that we have a fast reaction time for the Nevo radar, it's working perfectly here.
Exactly.
We do stay with the coal handling system, and here we do have an application in a drop hopper, and some other customers, some other brands did try to solve these application, and it was a kind of a little bit tricky here, because you see here the question mark, the 3 big question marks, and another brand, and it did not work really good. And why did it not work really good? Because we need an L2, so an inactive part here in this application that was not given. And we got false signal because the mounting position was too close to the silo wall. And when the material is coming, and due to the fact that we have a stainless steel lid, so we got a signal, but not always the correct signal. And then UWT came and had a deep look into this application, and now solved it with a standard RN 3100. But here in these, we need an inactive part. So with UWT RF3, that's the L2 part, and also a longer L1, because it's kind of the same like you're having with the RN3, for example. You need a sensitive unit. And with an RN, you can adjust the sensitivity by the vein. The bigger the vein, the more sensitive the unit is. And also for the RF3 version, the longer L1, so L1 is the active part, the more sensitive it is. And also what we need here is a rope version, so L1 is a rope version, because we do have abrasive material here in this application. Is RF the only version, or what would you recommend as product manager here?
RF is of course a good solution here in this application. Like we have here the typical application, a conveyor belt transfer station. So we did install a lot of RF sensors, but we can also use the Rotor Nevo. So with a rope version that I have here in my hands, so it's pretty robust, the strengthened rope version as an option for the Rotor Nevo. And in this application, it was necessary because we had some materials, that always came into contact because of the fast filling with the rope, and to keep it flexible and to avoid any mechanical damages, we had to use the rope version here in this application. So RF and our Rotor Nevo, perfect solution for those type of application. Although because they are reacting pretty fast, you can here you have for the Rotor Nevo different rotation speeds. So when we have like 5 times per minute, and it reacts even faster. So this is the option we also used here.
Fast reaction time. We have a constant flow of the material, so we need a fast reaction time. So RN, RF, perfect solution. The next one, coal handling system. So you see, that's really a guideline. We have so many applications only in this coal handling system. At the end, we have more than 100, 200, 300 measurement points, and we have many possibilities to place UWT here. So also in this coal feeder. So here we have a main challenge because we do have a negative pressure inside. We do have high dust, and we have a heavy mechanical abrasion here.
Yeah, more or less always the same challenges, but yeah, here one specialty also came. We had to mount the sensor sidewards, so we could not use like a rope version, so we had to use almost standard shaft version. And what you can see on the right picture, we installed a little bit of a protection for the shaft here again to avoid any influences, any mechanical damages. Negative pressure, no problem for the sensors. Yeah, they can deal or handle negative pressures up to minus 0.9 bar. And also again easy to install, abrasion resistant due to the stainless steel materials, and also build up is no issue for the RN or the RF. So Volta Nivo and the capacitive RF Nivo sensor, again solutions here for this application.
Yeah, even when you have build up on the unit itself, what does make build up makes only the vane bigger, and the bigger vane, the more sensitive it is, but build up does not bother rotary pedal at all. Next one for coal handling system. Now we do switch to continuous level measurement. Here we do have also a huge challenge in the pulverized coal storage. We do have fast and frequently freezing speed. Then we have high dust. High dust is always a challenge. What can we do with dust? Do we get a really reliable measurement, especially when we have a continuous level measurement? And maybe we do get wrong measurements because of these dusts. But Nicholas, what options do we have when it comes to application like this? What would you recommend here?
Yeah, here we have two options for continuous level measurement. So the NivoBob 3200 with the great feature of the tape cleaner. So high dust content, the tape cleaner just cleans the tape, so we get no false signals or no pollution inside the mechanical housing. This is the effect of the tape cleaner. What we can also do, we can have a redundant system, so combine a continuous level measurement, level transmitter with a level limit switch. This is what we did in this coal dust silo here. We installed the NivoBob, and in addition the level switches the RF Nivo, so as a full alarm, and the NivoBob for continuous measurement. With the tape cleaner, here you can see short video, a short animation, and then a real video of how the tape cleaner works. This is how it looks like. It always drives in and out the socket pipe, and when the tape is really dirty, then the tape cleaner cleans the tape, gets away all the dirt, and this also guarantees a long lifetime of the sensor. And here you could also see that it tape cleaner drives in and out of the socket pipe all the time.
And we do also for the NivoBob 3 series, we have the possibility to have also air purge. So that prevents that dust is coming into the mechanical chamber of the NivoBob 3. So that is also a great feature we can use here.
And of course, for the Nivo Radar, we have the option with the air purge. So Julian, you show it. So if we have like dusty material that covers the vane, and we have, maybe you can see it in the camera, these small holes here where we can then just get rid away of the dust with the air purge connection here. The air purge connection is always integrated in the sensor, so you can also order it afterwards. So when you notice that you have some problems with the dust, you can just order it afterwards.
Exactly. Yeah.
And then you have no problems with dusty build up around the lens antenna.
A little bit dust is no problem, but we have really a thickness of dust, then it can affect the measurement. But the dust is so low from the side of decay value that it measures through the dust. The next application is the ash handling system. So we have an economizer ash system here. We do have huge challenges here because temperature up to 350 degrees. We have a high dust like we talked before, and high corrosive material, and also a strong mechanical impact here on the unit. And we do solve this with two different units.
Exactly. Again, RotoNevo, RF Nevo. So here again, the modular design is to mention. So you can see the different installation situations. So on the left picture, we had to mount it, a little bit angled inside this vessel or inside this hopper. In the middle, we had a longer socket, so we could also use the RF Nevo with a longer L1, so the inactive length, and on the right side then vertically. So all type of mounting positions, installation conditions are possible with our sensors due to their modular design here. And high temperature version, RotoNevo, and again, RF Nevo, we have the high temperature versions there. And the RF Nevo comes with the ceramic ceilings to withstand those temperatures, as well as the RotoNevo, and build up resistant, both the RF with the active shield technology.
Yeah, the normal RF 3100 series come with more than 250 degrees, and then the high temperature, the 3300, up to 500 degrees Celsius. But the electronic part is the same. You only have 4 steps to do the commissioning. You do with that high level or low level. Then you set with the time delay from covered to uncovered or uncovered to covered or on both sides. Then you set the time delay, and then you set the density. So the switching point, picofarad switching point from uncovered to covered. So only 4 steps to do the commissioning of the RF 3000, and it's a plug and play unit. That's also the reason why so many RF3 units are used here in this coal industry.
Yeah, really simple to install and to commission.
The next one, also flash handling system. We do have a low density of the ash. We do have a low dielectric constant. Well, how can we measure low dielectric constant? We do come with it to this topic in a minute. And we have also easy, as it's a build up. We also have build up here, and also high temperature and pressure. So very many different different process condition that comes together here.
Yeah, you already mentioned the decay value. You have a nice unit here besides you. Maybe you could explain a little bit about this element here. This.
Just a second, I will show you this. So that is from UWT. We call it Arminizer because this is made from Armin, and we can measure the decay value here. So when you are not sure about the decay value of the material, you can send us a sample, and with this sample we have the possibility to measure the exact decay value. For example, when you are not sure, is the decay value too low for radar, or is the decay value too low for the RF, for example? We can say what is the decay value, the exact decay value. Of course, we need to put some other application details into consideration, but if it's decay value 2.5 or is it 5, it makes a huge difference. And with this Arminizer, we can measure the exact decay value.
And also interesting, the Arminizer was built from the electronic of the RF Nevo.
Exactly. Thanks for the hint, Nicholas. That's the RF electronic, and Armin did some special work on this to measure here the decay value. Not only to say if it's a covered or uncovered, we can say exactly what is the decay value of the material. Next one, we do still stay with ash handling system. We do have here a main challenge here in this pneumatic transfer pump, that we have light material. We do have a low dielectric constant. Also, it's very, very easy on the unit itself to have a build-up, and we do have a temperature and pressure again, and it's a small silo. And when it comes to small silos, we do also have the topic for vibration, and for 2 units, we do have the possibility to go for a separate housing. So with the RF, we can order it with separate housing, so that puts the electronic part away. And also with the VN 1256, we do have the possibility to also put the electronic part away, even when you have some vibration or when it has higher temperature, because the housing can only hold 80 degrees, and we need to make sure that the housing is away from the temperature.
Exactly. And I want to point out one more challenge here. So this is the build up. So RF has the active shield technology, and maybe you will think of VN, what can we do with build up VN? We have the possibility here in our VN. You see this little red element. You can here set the sensitivity in two values, so high and low sensitivity. So when it comes to build up, you should use this the low sensitivity, so that it does not react so quickly, and then you get reliable measurement results even when we have some build up around the forks, although it's not recommended to use it with really heavy build up. But you have the option here to go for a sensitivity adjustment, and then you can also handle some build up around the forks here.
Next one, ash handling system. In the ash silo, we have a low dielectric constant, but now we know when you're not sure, just send us a sample if it's possible. And we do have also particularly light material, and we do have, it's a fine ash silo, so different bulk sizes where you also have different possibilities to measure if it's a continuous level measurement, if you need it all the time, or also with a NevoBob where you can set it 1 or 2 times a day, and that's good to go.
Yeah, different options here, NevoRadar, NevoBob, and also the RotoNevo, the special version, the 3005. Perfectly designed for those loading telescopes. So we get one solution here, all the solutions out of one hand. So continuous level measurement, point level measurement, and also then the emptying process of the fly ash silo.
Exactly, a really compact solution here in the RN with a special name. Now we do steam and water system, because we also have possibilities to measure continuous level measurement and point level measurement for liquid application. So we have here condensation, we do have typical steam, we have high temperature, high pressure, and we do also have different installation conditions here. We have a steam boiler, with 2 units, UWT units installed for point and continuous level measurement, and also the steam boiler in general, where we used UWT devices. Nicholas, what kind of units did we use here?
Yeah, here we used the Nevo Guide. So the Nevo Guide is perfectly designed for the steam and water system in a power plant. What we have here, we have high temperature and high pressure. So we have 1 unit for pressures up to 100 bar, and then the really heavy duty version for pressures up to 400 bar. They do come with a steam boiler approval, so you can use them in steam boilers. We do have a steam compensation, a special feature. So when we have a lot of steam inside the steam boiler, then we have the steam compensation to get accurate measurement results. You can install it also in bypass, and so yeah, pretty flexible to use here, and in combination with the RF8, so our point level sensor, we do again have this redundant system for the steam and water system. So also Nivo Kappa would also be a solution if the temperature and pressures are not that high. Nivo Kappa could also work.
Nivo Guide 8, RF8, perfect solution here to have a security unit, the RF8, and a continuous level measurement Nivo Guide. Easy to do the adjustment. You need to set it the high level and the low level, and you do the and then it's good to go. All right, next application. We do have also steam and water systems. So we have a liquid ammonia tank, and we do have CO2 here in this application. We needed a high sensitivity because the material is really expensive, and also the difficult installation condition. Here you see here a bypass. And Nicolas, how did we solve these?
Yeah, again, we can use the Nivo Guide 8 here, this application. So we have also one specialty here is the SLOD, the second line of defense. And this is the optimum protection against diffusion of ammonia, because it's a very, a gas that likes to go out, and it's a very small gas. So we need to have a protection against this diffusion. This is the second line of defense. Bypass installation, perfect for the Nivo Guide. You could also use a coax probe here, and many options. You get the same effect with a bypass than with the coax, so the energy is more focused inside those small coax tube or inside the bypass, so you get even more accurate and more reliable measurement results in those type of installations.
All right, good. Other system, just give you an excursus. It's other system. Also, we have also a tube oil, a gearbox. Here, the oil has a low decay value. The challenge here is that we do have a long socket, and we have a high viscosity material here. And we do also, UWT can also provide here a unit here that have a continuous level measurement. And Nicolas, what did we use here?
Yeah, here we used the Nivo Kappa, so capacitive measurement technology, PFA coated, so no risk of buildup. We have active shield technology, and it's easy and reliable, simple to adjust. So we have a display also that always shows the capacity, the measured capacity. So also a very reliable solution for those type of applications.
And now we do come up with the new liquid line CN7, because as you know, you have the chance to win a CN7, brand new CN7. And Nicolas gonna talk about some interesting information about the units, and you need to listen carefully, because maybe that's a hint for you when it comes to the questions at the end of the webinar.
Here our new CN7, our new sensor for liquid applications. So in coal-fired power plants, we do also have acids. So acids, they are normally very aggressive, so aggressive environment. And for those types of application, we have the new CN7 7121. So it's fully made out of plastic, so resistant materials, so PVDF, what we use here for the full sensor. We have the tip sensitivity, so you can also install it in non-metallic vessels. So this is a big advantage of the sensor, in combination then with the active shield technology, where we also implemented in the sensor. It's a plug and play sensor with an M12 connector. so pretty simple to install and easy to set up. So one solution for acid applications, and also another solution from our new CN7 series is for water pipes. Yeah, due to the compact design, so it has a shorter probe than the old one. We have a smaller process connection, so 0.5 inch process connection, stainless steel PPS probe. So this one is a little bit more robust than the complete plastic version. Also plug and play. So two possibilities here for the CN7 to be used in those in the power plants. So yeah, nice sensor, and yeah, hope you listen carefully, because we will now go on with our
So let's start with an easy question. We talk about Nivo Bob 3. So you know that the standard motor holds around 3,500 hours. And now question is, when we have a brushless motor, how long does it last? Is it A, 10,000 hours, B, 15,000 hours, C, 30,000 hours, or even D, 60,000 hours? Okay, question number 1 is done.
So take your time and please, yeah, write the right solution or the right answer for this question. So we have 4 more questions to go.
Questions number 2, we do talk about remote version. So we have vibration, we have high temperature. We have 2 units that UWT is providing as a remote version. Is it A, RF and VN? Is it B, mono Nivo and kappa Nivo? Is it rotary pedal and VN? Or is it Nivo guide and RN together? What do you think? Question number 2, remote version.
We also talked about it during the presentation. If you can remember, then you will have the right answer here.
Question number 3, quick start menu RF3. How many steps you need to do the commissioning? Is it only 2 steps? Then you pick A. Is it B, 4 steps? Is it C, 6 steps? Or is it D, 8 steps? RF3, quick start menu. Thank you, Nicolas. We talked about CN7 redesign, and we're also having a process connection, so really small process connection here. What is the minimum process connection we can provide? Is it A, ½ inch? Is it B, 3/4 inch? Is it C, 1 inch? Is it D, 1½ inch? It's only for CN7, for the CN7 redesign.
For our new compact limit switch for liquid applications.
And if you win it, you will get also the smallest process connection that it is available. And last question, last but not least. Today we are introducing our new capacitive CN7 sensor series, benefiting from much more than just a facelift. It now comes with a new range of new models. We have new features, and we're also having the latest ... technology on board. Is it the latest TDR technology? A. Is it B, the latest ABS technology? Is it C, IO link technology? Or D, is it the latest radar technology? All right. So now you have 10 minutes time to send us the answer. Send an email to export@uwt.de. These are not the correct answers, so ABBA and D is not correct. And if we have more than one winner, the lot decides who's going to be the proud winner of the CN7. And I'm pretty sure you will have a lot of fun with this unit, because it's absolutely amazing. So our technical department put so much work and effort and money and everything into these new units, and we have so many possibilities to bring these in the market and have a great start with a new CN7 redesign. So it took a few minutes longer, but I think it was worth. And thank you very much for taking part here in this today webinar. Many information. We also put this video on YouTube, so you have the chance to look it up, or if you like the presentation. If you have any questions, Nicholas and I will be happy supporting you. If you have any questions, we are here helping you. And from my side, thank you very much. Where you're watching, have a great start in the day. Have a great afternoon. Have a good evening. And we just stay in touch. And thank you very much. Talk to you soon.
Thank you. Bye-bye.
Thanks. Bye-bye.